Hello, welcome to this tutorial on how to build linear models in Excel. I'm Dr. Dami Kabiawu, and I'll be taking you through a step-by-step process of how to translate the models into a spreadsheet model, and then how the data into a spreadsheet model, and then how to use Solver to solve an optimization problem. The examples that I'm using today is from chapter 19 of the textbook Operations Management by Williams J. Stevenson, and I think this is the 13th edition. So the model we're looking at is for this company. It's a product mix function. The company manufactures two types of computer systems. We will call them type 1 and type 2. And down here are the specs and the resources available. So I've got profit per unit, assembly time per unit, inspection time, and storage space. So profit will be used to create our objective function. We are trying to maximize profit. And assembly time, inspection time, and storage time, those three things are finite resources because we have an allowance for it. So this picture here tells us how many hours are required of assembly time for product 1 and 2, and inspection time and storage time. So I'm going to go through it step by step. First, we'll put the data on the spreadsheet. Then we are going to put some formulas in, and then we are going to invoke Solver and have it do some of the work for us. So first things first, I like to have my decision variables, which is the number of type 1 and type 2 items to produce, at the top of my spreadsheet. So I'm just going to go here and say, sorry, I got to move things around a little bit. Type 1, that's the product. And then I'm going to have type 2, just drag it across. Awesome. I'm going to color this yellow just so I know where I'm going to put the values. These are my decision variables. Now the additional information that I have is profit, and I have information on constraint, so assembly time, apparently I can't spell. We have inspection, we have storage. Now I'm going to put all the information that pertains to product 1 under product 1 and product 2 under product 2. So the first thing I'm doing is getting all of the data on the spreadsheet, and then I'll include some calculations. So the profit for type 1 product is $60. The profit for type 2 product is $50. Now, just because I'm extra, I'm going to take these and format it as currency. I feel better now. Now it takes 4 hours of assembly for type 1, 10 hours for type 2, inspection 2 and 1, and for space it's 3 and 3 for both. Now this will be my constraint. I'm going to move the data down a little bit so I can label things. I like everything in its place. So constraints, will be here. I'm going to make it bold. And I'm going to put some resources, available resources. You'll see why I put some space between the two. But I'm going to put it here. Bear with me for a minute. Assembly time, maximum is 100. 22 hours of inspection and 39 cubic feet. Now, I've got all the data up. I've got all of my parameters up. Profit and assembly time requirements. I've got the available resources. Now I have to go back and build the formula for the objective function and also build the formula for the constraints. Now, when you do an optimization problem, you're trying not to violate the constraints that are stated in the problem. We don't want to use more than 100 hours of resources. How do I know that I'm using less? I don't, unless I know how many I've used. So we're going to figure that out in a minute. I'm going to start by putting 1 in for the number of computers produced. That simplifies the calculations that I have to do. So I always start my calculations for decision variable by assuming that I produce type 1 of the first and 1 of the second. This also helps me figure out if my formula is roughly correct when I'm done. So now let's do the objective. And it's to maximize profit. So I'm going to remind myself that I'm maximizing profit. So we need a formula for calculating profit. Profit is number of items produced multiplied by the profit on the first one plus the number of the second item produced multiplied by the profit on the second item produced. Right? It doesn't violate the order of precedence in calculations because the multiplications get done first before the additions. So that's why I didn't put the bracket in. And I know it works, right? Because 60 times 1 plus 50 times 1 is 100. And I can change this to 2. If I change it to 2, it'll be 120 plus 100, and I should have 220. So my formula works. Now I'm going to use Excel's equals formula text. This is totally optional, but I like to see the formulas I'm working with while I'm working with it. So I've just put up here the formula that I'm using to calculate profit. This is an FYI. I'm going to make it italics. I'm going to make the font less, not as black, and I'm going to make it small. So it's not, a little bit smaller. It doesn't take up the attention. It doesn't take the attention away from what I'm doing. Plus, this is my objective. So I'm going to change the background formula for this. Now, whenever I do linear programming problems, I tend to stick to the same type of data set. I tend to keep my color coding the same so that whenever I pick up any of the programs I've done before, it's easy for me to see where the decision variables are. It's easy for me to see which one is the objective function without having to look at the formulas. So I like consistency. It's not required, it's just an optional thing that would make your life easy and make your spreadsheet work more efficient. So we've got that. Now I need to calculate how much assembly time I've used. Now, by the way, Excel has a function that does what we've just done with the objective function. We'll take the value at the top and multiply by the value at the bottom. And I prefer that. Again, I like efficiency. Don't have to use that formula. You could just do the math direct. But I'm not. I'm going to use Excel's sum product function. Imagine that you have 20 decision variables. You don't want to be doing the multiplications one at a time. Sum product allows you to pass Excel 2 arrays. It would do the product of the pairwise product and then sum them together, and that's why it's called sum product, which is exactly what we're doing here. So I'm going to go sum product. As soon as you start typing, Excel gives you an option to select something that looks reasonable. So take the values at the top, multiplied by the values at the bottom, and you get 220. So the formula works. It's just a little bit more effective. So I'm going to move this a little bit to the side. I know you can't see all of my screen, right? But this is the data for the resource up here. And at the top of that is the data for the time needed for each product. I've transferred everything to the spreadsheet so we can just ignore In fact, I'm going to move the questions to the side. We can just ignore the questions because I don't need it anymore. I've transferred everything. Now, more color coding. This data is given in the problem, so I'm going to color it blue, light blue. All my data, if it's given, I have a preference for using light blue to mark them. So this is given in the problem. These are informations given. And then anything else that is not color coded is an interim calculation. What do I mean by that? Well, I want to know how much assembly time I've used so that I can figure out if the constraint is violated at some point. So I'm going to say is equal to the number of items I produced multiplied by the assembly time for the first one, the number of items I produced multiplied by the assembly time for the second one. So I'm adding them together. Let's see, is this working? Oh, I'm sorry, times the assembly time for the second one. So if I produce 2 of item 1, I would use 8 hours. If I produce 2 of item 2, I would use 20 hours for a total of 28 hours, which is exactly what I have here. So notice the similarity between this formula and the one I used for objective function. I am just going to use Excel's sum product to accomplish the same thing. So sum product of the types, comma, and assembly time, press enter, same thing. Now I want to copy the formula down, and I'm going to tell you what's wrong with the formula in a minute. Excel allows you to drag down a formula and it would copy it relative to where you are. Now when I double click on this, guess what it's done? It's multiplied my inspection time by profit, not what I want to do. In order to figure out how much inspection time I've used, I need to multiply the inspection time for each item by the number of the items I've produced. So it should have been 2 times 2 plus 2 times 1. That gives me 4 plus 2 is 6. So I should have gotten 6. I don't, because when I copied the formula down, I copied it as a relative address. Now, there are 2 remedies to this. The blue borders up here, I want it around the yellows. So I'm going to drag it up. See, now it's pointing to B2, C2. I'm good. Press enter. It works correctly. The other option, in case you have numerous constraints and you want to do the same thing, is to use absolute addressing. If you look in the sum product function, Excel uses B2B, the relative addressing methodology. If you copy formulas from top to down, it will move all the references in that formula down or up or to the side relative to where you started, right? I don't want to do that. I want the address for my decision variables to be permanent. In other words, as I copy the formula from the top to the bottom, I want it to always refer to B2, cell B2, and C2 for the number of items produced. Whereas the constraints, I want it to move relative to where I am. So I'm going to click on B2, press F4. If you're using Mac, you could use function F4 instead of just F4. I'm going to click on C2 and again hit F4. And what you end up with is the $$ addressing system. $B, $2 means that Excel will point to the absolute address B2, C2, and when I copy the formula, it will keep that address as absolute. So the $$ marks those cells as absolute. This is not an Excel class. I'm giving as much information as possible, but I'm teaching linear programming. So if you're not sure, you should read up Excel's relative and absolute addressing system. Click on this and just drag it down. Now, if I double click on this formula, it points to the right cell. You should always check your formulas after you've copied them. Double click, right cell, awesome. I'm going to leave these as white because these are my formulas. Now, these constraints are less than or greater than constraint. Looking at this spreadsheet that I've built, I can't tell, right? So I'm just going to put the equal, less than or equal to sign. You can use less than or equal to. In other words, type the less than or equal to button like so, less than or equal to, or if you're extra like me, you would put a symbol in there. So I'll just do insert symbol, symbol, and I want this symbol here. I think you will find it under the maybe normal math characters, I'm not sure. So click on that, insert. I've used it so much it comes up easily. And close. Ooh, got carried away. I've inserted so many of it. Now that it's done, I'm just going to copy it down. And because I like everything to look clean when I'm building stuff, I'm going to center all of my data. So select everything and center it. Done. Now, how about I give you the formula for this cell here? Just this once. I'm going to insert a cell in here. I'm going to use the equals formula text because I've got formulas in here to print out the formula so that you can see the similarity. Okay, that's the formula. Again, it's black and bold and da-da-da. I want it to have the same format as this. Since I have a format that I like, all I'm going to do is click on that format, click on the paintbrush, and paint it over the formulas. So that is the formula behind these cells here. I want the number I produce to be less than or equal to. Now that I've done that, now that I've done this, how about I check that the model works? Because in order for Solver to work, you have to build the math correctly, and you have to make sure that all of your formulas are connected to the correct cell. You've got to build the math correctly. Once you've done it, Excel will help you find the optimal solution, but it won't build the math for you. So if I make one of item 1, did you notice that all of my constraint used? I think I should probably call this used. Resources used. So use the short for resources used. And I'm going to make that bold because why not? Okay, and profit has gone down. If I make 1 of 2, it correctly pegs that I've used 14 assembly hours, 3 inspection hours, and 6 cubic feet of storage, and my profit for one item is 110. If I make this 10 and 10, it calculates, but notice what happens here. I violated this constraint, that constraint, and the other constraint. It did calculate the profit correctly, it just isn't checking that I have the optimal solution. Solver will find you the optimal solution, but the model works even though right now we're violating all constraints. What if I do 10 of type 1 and 1 of type 1 and 10 of type 2? I'm violating only one constraint, but still this won't work because you can't use more hours than you have. Done. Now let's go invoke Solver. Solver can be found in the Data tab. Click on Data, and I don't have Solver because if I had it, it will be under the Analysis button. Now, I'm using OBS Studio to record right now, and I'm recording one window. So I'm not sure if you're going to be able to see the steps that I use when I invoke Solver, but I will talk you through it. If you have a Mac, Solver is available as an add-in under the Tools tab. So Mac people, you should be looking for Tools. Under Tools, there will be Add-in, and you can then add in Solver. If you are using a PC, you need to go to File. Then down at the bottom here, you will click on More. If you have the newest version of Microsoft, you will have More. If you have an older version, you would have Options. When you click on More, you don't see it right now, but there's a pop-up At the top, there's feedback and there is options. What we want to do is click on the options button. The options button brings up Excel option. It brings up this backstage view or this wizard that says Excel option. And on the left hand side of it, you will go down until you find add-ins. Click on add-ins, and in the right hand box at the bottom of the add-ins, you will find a section called manage, and it will be Excel add-in. Click on go. In other words, you will find a box with several drop downs. It defaults to Excel add-in. There's manage on the left hand side of the box. There is go on the right hand side. So you want to do manage Excel add-ins and click on go. When you click on go, you have another box that pops up that says add in. Right there, you can select which option you want to add in. You will have Analysis Toolpack, Analysis Toolpack VBA, Euro Currency Tools, or Solver. I'm going to click on Solver, do OK, and like magic, Solver will appear in the Data tab in the Analysis section right here. So when I click on Solver now, it brings up a box. Oh, goodness. And you can't see the box. So I'm going to have to stop and continue this in a minute. Okay, and we're back. So let me talk you through adding a solver again. If you have a PC, go to File. We are going to go to More. Click on Options. This is the Excel add-in options. Go to add-in, Excel options, sorry. Go to add-in on the left. Down here you will see Manage Excel add-in. Click on Go. Brings up this wizard and you can select Solver. I've already added Analysis Toolpack in the past. So now I'm adding Solver, which I've already done. Click OK. Solver shows up under Analysis. 1 minute. Now that we have Solver, we're going to click on Solver and it opens up. Now, the top is where you put the objective function. The objective function that Solver expects is the link to your calculation. So write this box where we have the formula for profit. It has to be a formula because you're going to tell Solver to maximize or minimize the value in there. Okay? So we're going to maximize profit because it's a maximization function by changing the decision variables. So in other words, we want to change the quantity of type 1 and type 2 that we produce and then maximize the function that way. If you look in here, right, we want to change these values, and because it's linked to the objective function, every time we change those values, the profit will calculate. Now, if I had no constraints in here, I just go solve. Do you see what happens? Excel has no answer because infinite production gives you infinite profit. Okay? Infinite production gives you infinite profit. Excel can't deal. It stopped after a while. So let's go back and be a little bit more reasonable. This is a tad unreasonable. Click on Solver. Go to profit. So this is the profit cell. We want to maximize this. Click on maximize by changing these cells. You can put it in as a comma separated list, but one of the reasons why I like to put my decision variables next to each other is because Excel has this beautiful thing. It allows me to select it as a group. So I'm going to click on the first and drag it to select the two, B2 and C2. If I had 10 decision variables, I'll just drag it across and then I don't have to put it in one at a time. I hate doing that. So now, constraint down here says set objective by changing the variable cells subject to the constraint. So we're going to add all the constraints. Again, we could go in and say my amount used. There's a formula here. must be less than or equal to, like we're doing. So see, this is my amount used, must be less than, you can select different buttons here, or equal to my amount available. And then I'll do OK. See, it shows up. And then I can add a second constraint. This value must also be less than or equal to this value. Add, and then I can say the third value must be less than or equal to this value and say OK. So always my amount used, oh, constraint must be a number. I didn't put anything in here. Now, click OK, and I've got all of my constraints. Notice that everything in Solver here is a link to a cell. I could have typed the values in here if I wanted to, right? Let's take the last one and do a change. I could have said that my used has to be a calculation. So the used in here must be less than 39, and that would work, no problem. But when you do this, you lose information. You have a spreadsheet with calculations, no way to figure out what you're doing, no consistency. It's not effective. It's not the best way to design. So I'm going to do it the way that I like, by pointing to the cells, okay? So I could just say change and click on here and do, and say this amount used must be equal to amount available. Say okay. So now I've got all of my constraints in here. Finally, this is my non-negativity rule. Remember, when you build a linear programming function, one of the assumptions is that you have a non-negativity rule. So if you click in this checkbox here that says make unconstrained variables non-negative, it means that your decision variables, type 1 and 2, that cell, the values that it brings back will be positive values. Now, select a solving method. Simplex is used for solving linear programming problems. So Simplex LP is the choice. If you forget and you leave GRG nonlinear, it would normally work. But then that takes a lot of brain power. It slows the computer down. So you really should use Simplex if you're working with simple linear models. Right now we have 2 decision variables. It doesn't really matter, right? If you're working with, I don't know, 10,000 decisions, which is, okay, a little bit excessive, but Excel could do it. If you're working with 10,000 decisions, then it would take a long time for GRG nonlinear to work, when Simplex will work just like that. So let's select Simplex, because that's the proper thing to do, and hit solve. We're going to come back to what these reports mean later on in the lecture. Not here, but later in the lecture. But there are 3 reports. One is the answer report, one is the sensitivity report, and the other is the limits report. And we'll come back to it. Click on answer, sensitivity and limits. I'm going to do OK. It says keep solution. Yes, it gave us a reasonable solution. And these here are the reports that it's going to print, and we'll talk about interpreting the reports later on. So click OK. The 3 reports show up: sensitivity report, limits report, and the answer report. And as well, back on in your model, you have your optimal solutions. I think this just happens to be a whole number by chance, because linear programming might give you back fractional information. Okay, so it says by producing 9 of type 1 and 4 of type 2, we maximize profit. You cannot do better than $740. So click, then we type $740 just as a reminder. Now let's take this and change it and see what the calculation looks like. Before I do that, notice these are the resources used if I build 9 of type 1 and 4 of type 2, and here are the available resources. Can you see? Was not violated, was not violated, was not violated. Now let me go back and give you one more piece of information. Wherever you see the amount used being equal to the resource, you call those binding constraints. And where you see the resources used less than for a maximization function like so, where the constraint has the less than or equal to sign, you say you have slack. So in here, we could produce more. We can't because obviously there is no slack for the other two constraints, right? But there is slack in the first one because you've used less than is available. For the other two, these constraints are binding. The only way you can maximize profit is to loosen the constraint. In other words, if you can somehow find a few more hours for inspection and a few more hours for storage, then you will get a higher objective. So the bottom line of the summary is your objective function, this is the highest value. Even though, actually, let's leave it there. This is the highest, this is the best you can do with this objective. If I make 8 of this, I have slack, 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 less. How about I make 5 of these? I've got slack, slack, binding. I make 730, and before I made 740. Point is, it doesn't matter how you shake it. This is the best that you can do. Okay. So there is your problem. I've changed everything. I'm going to go back and run solver again. Data, solver, just for the fun of it. I'm going to remove all of this because even though I showed you that you could delete, you could do the constraints this way. If your constraints are put on top of each other like so, they are arranged on top of each other. Sorry, I've changed this again. If your constraints are arranged on top of each other and they all have the same sign, in other words, less than or equal to, then I could put it into my data in one go. I could put it into solver in one go. I'm going to do add. Make sure all of these values here are less than or equal to all of these values here. Again, Excel will do what it does with arrays. It will compare the top two and the second two and the third two. It's just more efficient to have one line of constraint than several. So anytime where you have the same signs, you want to try as much as possible to put your constraints right on top of each other or next to each other so that you can select them as a group. When you're using array functions in Excel, if your arrays are stacked on one side, they have to be stacked on the other side. And if they're put in rows on the one hand, they have to be in rows for the other one. So you can't have one row and one column. Not going to work. Okay, so solve. And we're done. Now, this time I'm not printing any reports because I already have the reports. I'm just going to do OK. Now, what happens if I can loosen this binding constraint? What if I can find 2 more hours for inspection, 24 hours for inspection, and 40 hours for storage? What happens to my model? I can use solver again to find me the best combination that will use up more resources if it's possible and give me a higher profit than the 740 that I already have. So hit solver. I don't need to do anything because right now my solver points to the right cell. I'll just do solve. I've already done it once. It remembers, do solve, do OK. Now it's saying, okay, rather than you build 9 and 4, do 11 and 3. When I do 11 and 3, guess what? I use all of these and even less of the assembly time because 3 doesn't need, did we use less? Yes, we did, because type 1 uses less assembly than type 3. So making 3 instead of 4 has an effect. So there you go. Now profit's gone to 773. We're good. So I'm going to take this opportunity and do the remaining 2 problems. I'm not going to talk as much as I've done because I'm exhausted now. So that is a lot of talking. So I'm going to do example 2 and example 3 real quickly with the same format and same structure, very simple, and here is your final answer. So example 2, we're going to build this. We've got 3 products this time, x1, x2, x3. I'm going to go product x1, I'm going to call it x1, x2, x3. Like I did before, I'm going to put decision variables here. It doesn't have to be. I just like to put them at the top so I'm not searching for them when I need them. Going to make this yellow. Go back, sorry. Save it in case I lose it. I'm going to make this yellow. I'm going to say 1, 1, 1. This helps me check that I've linked things correctly and my formulas are working well. I want to maximize profit, so I'm going to put profit up here. And for the first one, profit is $5. Second one, $8. Third item, $4. How do I know? It's conveniently put here in this formula. I can calculate profit by knowing how much the profit on an item is and how many of that items I've produced, right? X1 is the item, so X1 represents the number of X1 I produce. If I produce 1 X1, I have a profit of 5. So that shows me what it is in this formula. Now this is the mathematical equivalent of another formula. I've got labor resource. Product 1 uses 2 hours of labor, 2 uses 4 hours, 3 uses 8 hours, and I've got 250 hours of labor available. I can't use more than that. So I've got 3 constraints, 1, 2, 3, that I'm going to mark. For the product 3, I cannot do more than 1. So there are a couple of ways to put this constraint in, but I'll show you the 2 ways of doing it. And then the non-negativity constraint, I don't need to put that in because Solver will tackle it. So constraint, let's make this a little bit bigger. Sorry, this is the formula for a minute. Product X1, I can only manufacture 10 units. I'm taking this directly from the text. Okay, so I'm going to move this to the side again. And put all the data on the table. So constraints. Let's make this bold. Make everything here bold. My first constraint is labor. My second one is material. My third one is product 1. Now, I've got 2 hours of labor for the first, 4 for the second product, 8 for the third. Notice how I'm lining everything down, okay? Don't have to do this because I could just do the calculations and put it in one by one. This is just efficient. 7 for the second, 6 units of material, 6 pounds, 5 pounds for the third. And for product 1, every one of product 1 I make goes towards my used allowance. So I'm going to put used here. I'm going to reserve this here for the signs. It's less than or equal to. So I'm going to put insert symbol, less than or equal to sign. Okay. I'm going to copy that all the way down. And I'm going to do available. This time I'm not going to print out any of the formulas, so I don't need to make any space available. I like to have all my data in the center, so I'm going to do that. Go to the home page, select my columns, and center my data, just like that. If I double click between 2 cells, I can widen the cell before. So I want to widen cell A so that it contains the full text for constraint. So I'm going to move my arrow here until it changes to this weird cross. Double click on it. It expands so that it can accommodate this, the width of that data that is typed in. So now I'm going to do the objective, which is to maximize. And oh, I'm sorry, I'm going to move that over a little bit so I can write profit in here. I want to maximize profit. And the formula for that is we're going to use sum product again. Sum product, these values up here times this value. Now, again, I'm only putting 111 in here to make sure that my calculations work well. It's easy to do the math for 11111. So I always do the 111, format this as a currency, just to make sure that this is working. So change the color. Yeah, so that's why I do that. Now I know this is working. If I change this to 2, profit changes. Change this to 2. Change this to 2, profit changes. I know that my calculation works. So back to 1. It's always the math for 1 times 4 is easy, so I have a preference for using ones. So now I need to know how much of the resources I've used. I'm just going to go in and do sum product again. Ooh, sum product. And then I'm going to select these values here, comma, and these values up here. And when I'm selecting these values up here, I'm going to press F4 or function F4. I don't think you have to do command F4. I think it's function F4 or just F4. I'm using a PC, so F4 works for me. Close that, press enter. I've got the number used. And again, I correctly made these absolute address. So I'm going to copy the formula down, make sure it works. Excellent. Now, here is what's amazing about this last formula here. This constraint says that I can only have 10 of product 1. So I want to know how many of product 1 I've made so I can compare it, right? So I can put 0 in here. I don't have to. Excel puts 0 in there when it's doing the calculation. So it doesn't matter what is in here. It's multiplied by 0, so nothing happens. So the only thing that ever affects this is product 1 because the constraint is on product 1. So if I make 3 of product 1, it updates. If I make 3 of product 2, nothing happens, and so on and so forth. So I'm going to undo it because I still like the ones. Now, what are the number of units available? I've got 250 hours for labor. I've got 100 pounds for materials, and I've got 10 for products. So now, model is complete. I'm just going to color code stuff, make this light blue. As per usual, make these light blue because they're given. These are my formulas, so I'm not going to make it light blue. I'm going to leave it white and make these light blue. So I know that these are given, this is given, that's given in the formula or the case or whatnot. And this is the objective function, and these are my decision variables. Now I'm going to go to solver. Because I've used it to get before, it might be pre-filled with data, so you have to be careful to delete it. It's not, so that's good. It's deleted it because it's a new sheet. So click on profit. We are going to change the decision variables, and I've stacked my constraints. I'm going to add it in one go. Make sure this array is less than or equal to this array here, and okay. Remember to make this simplex, check the non-negativity constraint, solve. It works. Okay. Solver just said, if you want to maximize your profit and be efficient, just make 16 of product 2. Don't make product 1 and don't make product 3. In doing that, you will use all of the constraints here. So materials is a binding constraint. You will use all of it, and you will make none of these and none of that. Sound good? How about we ease the binding constraint? We don't have to because the case doesn't ask us to do it, but I'm going to ease it. Every time you change something, Excel Solver does not automatically recalculate. You have to go back and recalculate it, okay? It just says keep making product 2 because product 2 is the most profitable and it doesn't use that much materials. It uses less than product 1. So product 1 is never going to be profitable enough to be made. And maybe not product 2 as well. So there you go. There is your calculations. So I said something a minute ago. I said there are 2 ways to represent the product. Do you know what? I think this is a good way to build this. So we're just going to leave it here. So here is your spreadsheet model. Let's do the third one. Third example, a construction firm specializes in building and selling single-family homes. The firm offers 2 basic types of houses, model A and B. That's my decision variable. So I'm going to put that up here, model A and model B. I'm going to move this question to the side a little bit for a minute so that you can read it. And then I'm going to get rid of it, okay? Because I'm sure it's behind my picture. Yep, it is. So now you should be able to see all of the questions. A construction firm specializes in building and selling single-family home. The firm offers 2 basic types of houses, model A and model B. So we'll call this output or decision variables. I'm calling it output because it's what it's produced, but let's be consistent and use decision variables. Okay, click on here and make it yellow because I'm making all my decision variables yellow. Profit. For the first one, the house requires labor hours. So we'll say labor is our constraint. Stone. And we have lumber. Model A uses 4,000 hours of labor. 4,000. 2 tons of stones. 2,000 board feet of lumber. Model B uses 10,000 labor hours, 3 tons of stones, and also 2,000 boards of lumber. The firm has 400,000 hours of labor available, so we'll go with used as per usual. Available as per usual. We've got 400,000 available. Let's make sure I didn't go too far. I did have 1 0 too many, and remove some of the zeros because it's not. So there we go. Stone, we have 150 tons of stone, and we have 200,000 board feet of lumber. Okay, now I'm gonna make all of this center everything because yes, I'm going to put constraints up here. I'm gonna move these down by 1 because I like to have space. Make this bold. See what I'm doing? This is my style, so I keep everything consistent. The things I make bold, I try and keep them bold. The things I make different colors, I try and keep the colors going. The profit on model 1 is 3,000. The profit for 2 is 6,000. And again, if it's dollars, I like it to be in dollars. Just my thing. So there we go. Okay, so good. I'm going to format this. I like this formatting right here. So I'm going to format the thousands using that format. I'm just clicking on the paintbrush. I'm painting it on the values that I like so that it formats it exactly the same way. So there we go. My formatting is done. Now, I don't need this anymore. So I'm going to delete it to give myself more space on the screen to work. I've transferred the question into data on the screen. We're going to mark the data as light blue as per usual. Now let's start building all of the formulas. Let's start with the objective. We are going to have profit. That function is sum product of the decision and profit. I'm not using the 1 this time because I know that my formulas are right? I've done this so many times. But I will check when I'm done building to make sure that I did the right thing. Sum product of these values here, comma, times the decision variable. I'm going to make that F4, permanent address. Press enter, drag the formula down. And then this is less than, oh, by the way, got to check the formula, correct. Now this is less than or equal to. Again, go back, insert symbol, less than or equal to symbol, okay. I only need 1, I'm going to copy it all the way down. There we have the model. Now I'm just going to check it works by typing 1 and 1, and my calculation should be done. So now I'm going to format the objective function as a currency as well, because it is a currency, and I like my work to be clean, 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 clean. Okay, so there is the solution. Now, model works. Everything is connected. When I make 1, I use 4,000 of these hours, 10,000 of those hours, so 14,000 hours out of the 400,000 available. I use 5 pounds of stone, and I use 4,000 of the feet of lumber available. See? It works, works, works. The last thing I just have to do is format this. Sorry, format. Remove some of the zeros. Make it, centralize it again. Oh, it's a number. It's refusing to centralize it. But that's fine. So there we go. I've got my work done. Now, run solver by going to data. Click on solver. Select the objective, which I can't miss it because I color it the same every time. Select my decision variable cells or my changing cells, whatever you want to call it. Add my constraint because I know exactly where it is, because I do it the same way every time. Do OK. Make this simplex. Check the non-negativity constraint. Hit solve. It worked. OK. Done. Manufacture 37.5 of the first one and 25 of the second. Obviously, you can't manufacture 27.5. If you don't have enough resources, you've got to round down. You've got to round down. Okay? By rounding down, you use less, so you're good. So there we go. That is the solution. Check out my third example. Check out my second example. Looks similar enough. Check out my first example. Looks similar enough. This is my style. So when I go back to my linear programming models years after, and the complicated, simple, whatever kind of model, I can immediately tell you what is happening in my model because I use the same formatting structure. I use the same thing. I can tell exactly how it works. So you've got to develop your own style, but there ends our tutorial on simple linear programming